Okay, in 4.2, we're going to look at position, velocity, and acceleration. If you're in physics, you've seen these terms before, but they're based off calculus. Okay, so the first one is the position function. What they normally use is S, so S of t. S of t is just saying where the particle is or where it's located. Okay, and it's normally relative to something. So if I was moving along the x-axis, if S of something was 5, I would be at the positive 5. It could be located at -3, which would put it -3 on the x-axis, depending on the description in the problem. Okay, the next common function is velocity function. Velocity is how fast the particle is moving, so it's the change in location. So when they say v of t, they also mean S prime of t, the change in its position. And when you're thinking about the change in the position, and we're thinking how fast is the particle moving. Okay, and it could be positive or negative depending on if it's moving to the left or the right, or where it's moving relative to the description. Let me say, and its direction, because the negative does indicate the direction. Okay, now the next term is acceleration. You know when you press on your gas pedal that you are accelerating or you're speeding up. This is how your velocity is changing. So this is v prime of t. It's how your speed is changing. Is your speed getting faster, or are you hitting the brake and your speed is getting slower? Since this is the derivative of v of t, and since v of t is the derivative of s of t, this is also s double prime of t. Okay, and this is measuring how the velocity, how fast the velocity is changing. Okay, and really you're thinking like, am I speeding up or speeding down? Speeding up or slowing down? Okay, if it's acceleration is negative, you're slowing down. If it's positive, you're speeding up. Okay, let's look at what they might describe to you and interpret the context. Okay, so for example, 0, it says a car leaves home. S of t is representing the car's distance in miles away from the home at each hour. Okay, so I'm leaving home. Leaving home is my 0 part. So the first one is S of 1. S is my position. What is the 1? Each hour, so at 1 hour. So at 1 hour, what is S? The car's distance in miles. The car is 30 miles away from home. Okay, now let's consider if it says S of 3 equals 0. Okay, well this is at 3 hours, or at hour 3. Let's see, my car is 0 miles from home. Well, then my car is at home, so my car is at home. Okay, now let's look at v of 1. Remember, v is the velocity. Okay, so at 1 hour. Okay, the velocity is 25, and velocity is the derivative of the distance, so it's the rate of change. So the unit should be the units of s over the units of t, so this is going to be in some kind of miles per hour. Okay, so let me think, what is my car doing in miles per hour? Oh, it's moving or it's driving. So at 1 hour, my car is moving 25 miles per hour. And since it's positive, it's going away from home. Okay, let's consider when v of 2 is negative 10. Okay, so that's going to be at the second hour. Okay, now I don't want to use a negative in my answer. I want to describe what it means because it's asking me to interpret it. So my car is moving 10. But why is it negative? Well, positive meant I was going away from home. So negative means I'm moving toward my home. So at 2 hours, I'm coming towards my home at 10 miles per hour, okay? But the velocity was negative 10, but when I'm interpreting it, I'm gonna say a positive velocity and then explain why it's negative. What is the meaning of the negative velocity? Okay, the last one is a of 1 is 3, so that's my acceleration. Okay, let me just start with that hour 1, because that's the easy part. Okay, what is my car doing? Okay, a of 1 is the change in my velocity. So what am I doing? The derivative of velocity. My units for velocity were already miles per hour. But now I'm doing the derivative again, so I'm doing the miles per hour per hour. So I'm seeing how my speed is changing. Okay, so how is my speed changing? My speed is changing by positive 3. Since it's positive, my car is speeding up. At 3 miles per hour, or we could say 3 miles per hour squared because I'm doing per hour, okay? But I am speeding up because my velocity is changing in a positive direction. So if I was going 52, now I'm going 55. So my velocity is increasing, so my speed is increasing. Okay, now we're gonna look at the meaning of some of these values. So if I'm looking at velocity, the most base case we think about is a particle moving along an x-axis. Okay, so if my velocity is positive and I'm moving along the x-axis, then I'm moving to the right. So my particle is moving right. I don't know. And then the number will tell me how fast it's moving to the right. Okay, if my velocity is negative and I'm going along the x-axis, then my particle is moving left. And depending on the actual numeric value, it would tell me how fast it's moving to the left. Okay, now if the velocity is 0, then the particle is not moving. So the particle is at rest. It's just staying still. It has a location, but it's staying still in its location. Okay, if I want the average velocity, as we have done in the past, this would be S of B minus S of A over B minus A, because that's the average rate of change of the location over the time A to B. Okay, now what is the difference between velocity and speed? Okay, now speed is always positive. So it's actually the absolute value of velocity. Okay, if you're on the freeway and you're going 55 miles per hour, whether you're going towards your home or away from your home, you're still going 55 miles per hour because that's your speed. Whereas if your velocity was based on the movement from home, it might have a different sign. So this is just saying how fast the particle is moving. Regardless of direction. So on the x axis, this doesn't matter. This isn't going to tell me if it's going left or right. It's just going to tell me how fast it's going in some direction. Okay, now let's consider the next scenarios. Okay, what if the velocity is positive and the acceleration is positive? Okay, so say the velocity is positive and the acceleration is positive. Say I'm going 50 miles per hour and I'm accelerating at 3 miles per hour. So I was going 50, now I'm gonna go 53, now I'm gonna go 56. I'm gonna keep increasing my speed. So I'm gonna be speeding up because my velocity is positive and my acceleration is positive, so it's increasing me even more. Now what if it was negative in the same side? If my velocity is negative, I'm going to the left, some value. If my acceleration is also negative, if I'm going negative 50 and I'm accelerating at negative 3 miles per hour, I'm going negative 50, negative 53, negative 56. I'm still speeding up. I'm just going to the left. So if your velocity and acceleration have the same sign, you are speeding up. Okay, now what if they have a different sign? So say my velocity is positive, but my acceleration is negative. So I'm going 50 miles per hour, but my acceleration is negative. So it's actually slowing me down. Now I'm going 48, 47. I'm going slower and slower. So that's going to slow me down. If my velocity is negative, I'm moving to the left. My acceleration is positive. That's pulling me to the right. So that's also going to slow me down. So if they have different signs, your velocity and acceleration, then your particle or whatever the object is slowing down. Okay, next word, displacement. Okay, displacement is your net change in position. Okay, so if I started on the number line at x equals 3 and I ended x equals 5, my displacement is 2. This is my net change in position. So in between the 3 and 5, I might have gone back and forth and up and down and all around, but my net change in position is just where I ended minus where I started. So if it was A to B, it would be S of B minus S of A. And we care only about the initial and terminal points. Okay, let's look at an example finally. Okay, so example 1, this is a particle motion, and they're going to give you an equation to describe its location. So the position or the x-coordinate of a particle moving on the x-axis is modeled by the function x of t equals t to the third minus 4t squared plus 3 for t is greater or equal to 0, where x is measured in centimeters and t is measured in minutes. So this is telling me where my particle is on the x-axis. Okay, I'm going to find the displacement in the first 2 minutes. Okay, displacement is how did my position change? So I'm going to do, where am I due? First 2 minutes. So this is from when I started to 2 minutes. So my displacement is going to be x of 2 minus x of 0, because it's my ending position minus my initial position. Okay, let me plug 2 in to this function. So that's 2 cubed is 8. Minus 4 times 2 squared is 4 plus 3. And then I'm going to subtract 0 minus 0 plus 3, subtract 3. Okay, negative 8 plus 3 is negative 5 minus 3. So my displacement, or the particle's displacement during the first 2 minutes is negative 8 centimeters. And it's okay for it to be negative. That means that on the x-axis, it went to the left at negative 8 centimeters from minute 0 to minute 2. Okay, now what's the average velocity for the particle during the first 2 minutes? Okay, average velocity is going to be the change in distance over the change in time. So first 2 minutes is from 0 to 2, so x of 2 minus x of 0 over the change in time. Well, I just found the change in distance is negative 8. So this is going to be negative 8 over 2, which is negative 4. And then my units are the units for x, which are centimeters per minute. Okay, and this is velocity, so this is telling me this is moving to the left at a rate of 4 centimeters per minute during the first 2 minutes. Okay, number 3, let's find the velocity when t is 4. So this is an instantaneous velocity. Instantaneous velocity makes me think of derivative. Okay, velocity is the derivative of position. So let's do v of t. If I want that, that's the derivative of the position function. So if I go back up here, the derivative of this is 3t to the second minus 8t. Okay, and then they actually want the velocity at when t is 4. So I want v of 4, which is 3 times 16 minus 8 times 4 minus 32. 48 minus 32 is 16. This is velocity, so that's going to be the displacement per minute. Okay, so at exactly t equals 4, the velocity is moving 16 centimeters per minute, and it's positive, so it's moving to the right. Okay, now let's consider from number 4, find the acceleration of the particle. Okay, well, acceleration is the change in velocity. Okay, so if I want the acceleration, I'm going to do the derivative of the velocity, and they want it exactly at t equals 4. It's instantaneous. So the derivative of v of t, this is v of t. So let me find the derivative of this. That's going to be 2 times 3, that's 6t, minus the derivative of at is 8. So the formula for the acceleration of the particle is 6t minus 8. They want the acceleration when t equals 4. 6 times 4 is 24 minus 8. So that's 16. Acceleration is the change in my velocity. So my velocity was centimeters per minute. Acceleration is going to be centimeters per minute per minute. So I'm going to make that centimeters per minute squared. Okay, so at t equals 4, my acceleration is 16 centimeters per minute squared. Okay, now is the particle speeding up or slowing down at t equals 4? Justify. Okay, let me think. If I want to check if something is speeding up or slowing down, I'm going to check v of 4 and a of 4 and see if they have the same sign. Okay, so my velocity, v of 4 is 16, positive 16. A of 4, 16. They're both positive. Since they're both positive, this particle is speeding up. Okay, I'm going to justify. How do I know they're speeding up? I know they're speeding up because v of 4 and a of 4 are the same sign. Okay, velocity is positive, acceleration is more positive, so it's pushing it to an even faster positive speed. Okay, let's look at one more with a graph. Okay, example 2, particle motion from a graph. Okay, the figure shows the velocity of a particle moving on the coordinate line. Okay, make sure you're careful about what you're reading. So this is telling me the velocity. So at time 0, the velocity is 2 somethings per second. They didn't give me the units. Okay, but it's velocity. Okay, now what's the first question? When is the particle moving to the right? Okay, if I'm moving, I'm thinking of velocity. So let me think velocity. Okay, if I'm moving to the right, my velocity should be positive. So I'm going to look at this graph of velocity and see when the velocity is positive. Since this graph is a graph of the velocity, it's telling me the actual velocity value. So at time is 0, the velocity is 2. Okay, velocity is still positive. Velocity is still positive. Okay, when I get here, the velocity is 0. Then when I get here, the velocity is negative. Okay, so when is the velocity positive? It's positive from t equals 0 to t equals 1. Okay, and I'm going to say from 0 to 1. I'm telling the domain values when it's increasing. Okay, now let's look. Now the velocity is negative. The velocity is negative. The velocity is still negative. Right here, the velocity is 0. Okay, when I pass that point, now the velocity is positive again. And it stays positive till I get to here. So what do I think that is? I'm just going to guess that's like 4.6. So from 4.6 to 7, the velocity is also positive. I did not put brackets on this because like at t equals 1, technically the velocity is 0. And at t equals 0, I guess I could have put a bracket there. Okay, now let's consider the next thing. When is the velocity moving to the, or when is the particle moving left? If the particle is moving, that's velocity. If it's moving left, I want to see when is the velocity less than 0. Okay, the velocity is less than 0 when? Not here. This is all positive velocity. This is 0. Okay, it hits the negative, the velocity becomes negative right here. So from t equals 1 until we guessed 4.6. So from t equals 1 to t equals 4.6, the velocity is negative. And then it's positive, positive, and then back to 0. So it's only moving left from t equals 1 to t equals 4.6. Okay, when is the particle's acceleration positive? Negative or 0? Okay, let me think about acceleration. What is acceleration? Okay, I want the acceleration to be positive. What is acceleration? Acceleration is the derivative of the velocity or the change in the velocity. So I really want to figure out when v prime of t is greater than 0. And remember, v prime is just slope. So I want the slope of v of t to be greater than 0 for it to be positive. Okay, this is all for positive. Here, let me write positive underneath. Okay, so the acceleration is positive when the slope is positive of the velocity graph. So right now the slope is negative. We're decreasing. Slope is negative. Slope is negative. Slope is negative. Oh, right here, the slope becomes positive. So the slope is positive from 2 until I get to 6. Okay, now how about negative? If I want the acceleration negative, I'm looking at the slope of the velocity. So the velocity is negative, the slope of the velocity is negative from 0, negative, 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 decreasing until I get to 2. Okay, then it starts increasing. Okay, but when I get to 6, it starts decreasing again. So the slope is negative again from 6 to 7. Okay, now what about when the acceleration is 0? Now for the acceleration to be 0, I need the slope of the velocity to be 0. Does that happen anywhere? Negative, positive, negative. There's actually nowhere where the slope is 0. If you're thinking, like, what about right here at x is 2? At x is 2, there's one of those weird points thing. So there's no it's not differentiable here, so there's no derivative here at all. So there's no defined slope value at all. So this wouldn't work. If this were a nice curve, it could work. But because of that point, it's not differentiable at these points. There's no points at which the acceleration is 0. Okay, let's look at number 9. When does the particle have the greatest speed? Well, this is the graph of the velocity. So let's look up at 0. It has a velocity of 2, which means it has a speed of 2. Let's see, at t equals 2, it has a velocity of negative 2. But the speed is also 2 because speed is an absolute value, which is going in a different direction. So when does the particle have the greatest speed? At t equals 0 and at t equals 2. Okay, last question. When is last two. When is the particle speeding up? Okay, well, if they're speeding up, I want the velocity and the acceleration to have the same sign. Okay, so let's look at the beginning of the graph. So right here, the velocity is positive. Okay, now is the acceleration positive? Acceleration is the slope. So the slope here is negative. So right here, the velocity is positive, but the slope is negative, which means the particle is slowing down. So when is the particle slowing down? The particle is slowing down from 0 to 1. Let's justify this because the velocity and acceleration have opposite signs. Okay, now let's look at the next piece of graph. Okay, when I get down to here, the velocity is negative. The acceleration is also negative. So right here, the velocity is negative and the acceleration is negative. Since they have the same sign, the particle is speeding up. So from 1 to 2, velocity and acceleration have same sign.
Hello, folks. This is Mr. Polk. I wanted to let you all
Okay, let's look at the
know
next
that
piece.
today we have Holy
From
Days
2
College
to
on
like
campus today, and
4.6,
it is a career center. So
the velocity
please,
is
if you would like to
positive.
be a part
No,
of
the velocity is
presentation,
negative.
head over to the
But the
Career
graph
Center
is
in Code Court.
increasing, so the
Once
A is
again, we
positive. So they
Holy
have different
Days here.
signs.
So if
So
you would
that's
like to
from
visit
2 to
and be a part of the presentation,
4.6.
please come over to the Career Center in
And the
Code
same
Court.
reason, because the
Thank you.
velocity and acceleration have opposite signs. Okay, now if I look from here, the velocity is positive, acceleration is positive as well. So they have the same signs from here to here. So where is this? Also 4.6 to 6. And then let's look at the last piece. From 6 to 7, the velocity is positive, but the slope is negative. So they have opposite signs. So it's also slowing down from 6 to 7. Okay, so when the velocity and acceleration had the same sign, that was 1 to 2 and 4.6 to 6. The velocity was slowing down when the velocity and acceleration had opposite signs. So that was from 0 to 1, 2 to 4.6, and also from 6 to 7.